here.
Neat.
Yay! I was like waiting for you to say something so I could see if your audio was gonna register.
No, I had to get A, my YouTube up, and then B, little his royal floofiness over here is getting ready in a barking stance.
Oh, he's got a stance.
He is not happy.
Stance.
Do you have to use the restroom again?
A barking circumstance.
Oh, nice.
Barking circumstance.
That's nice. That's a good one.
Thank you.
I may randomly have to leave this episode. I don't know.
Okay.
All right. Well, new rule: every time Brandon has to just like, put your camera flap down and mute yourself, and then you can take a break. And then every time Brandon needs a dog break.
Hopefully, it won't happen. Because we had a good active morning. You went poop in the carpet. You went poop outside. You went pee. So yeah, he should be set.
Yay! We've all been through that.
I don't think we have anybody.
It's fine. Yeah, my parents there have a friends giving lunch thing or something to go to that they gotta get ready for. Yeah, well, they have grocery shopping to do. They just got home, but they have grocery shopping to do. I don't know what anyone else is doing, so it's a holiday weekend still, so
yeah.
We'll just get started.
Talking to ourselves.
All right, ready, Brandon, for a countdown?
Sure.
All right, in 5, 4, 3.
Good afternoon, good morning, good evening, what might have you. Welcome to, what is this, episode 6, season 6, Cosmos with Cosmos.
Woo!
I'm Brandon.
I'm Liz.
I'm Mike.
Yay!
We're here, we're alive, we made it, we're doing it.
Some of us are alive.
We're alive, our life dedication has completely changed last month to not focusing on, yourself or space, but instead focusing on little tiny meth raccoons that dwell in your house.
Oh, first time. Well, you're not necessarily a first time pet owner, but...
Oh, no, not at all.
But I mean, yeah, you've had a big... We just added an extra one to our zoo.
They may make an appearance.
We'll see. He's been pretty shy about coming in when we're doing this.
Well,
so
we've only done this once, though, with Indy, right? Or
yeah.
twice.
Yeah.
Yeah, but my guy is pacing behind me, so he'll make an appearance for sure. Hi, Mr. Frodo. Hi. Okay. All right, so we're going to see how the show goes with my meth goblin just right next to me and ready to bark.
Yeah.
All right, so with that, what are we drinking today?
Oh, shit. I forgot to think of a name.
All right. I am drinking what is called Quintessence.
Oh, nice.
Which is, a thought on dark energy. But basically, it is caramel vodka with a little bit of caramel syrup, apple cider, ginger beer. So, caramel apple mule.
Nice.
That's very festive.
I am drinking the cosmological soup.
Oh, nice.
Which is bourbon, maple syrup, and lemon juice. Technically rye whiskey, though.
Yeah, that's rye whiskey.
Rye whiskey.
What your dad bought?
It's good. Also, I would just like to make a note. Mike had made these pumpkin syrups for drinks for Thanksgiving, and they're good, but I've also discovered they work really well on vanilla bean ice cream.
Nice.
Just would like to plug that for no reason, for nobody, but... What are you drinking, Brandon?
I have a lesson in insignificance.
Ooh.
Which is really what this podcast episode is about. We haven't talked about it yet. It's about dark energy, but it's also about dark matter and other things that make us feel small, basically.
But if you think about the universe, that's your lesson in insignificance. But I like that.
And I'm going to keep looking to the side because what I'm going to call him, his fluffiness, may pee on my carpet. I don't know. So I'm ready to go, just in case.
It's just dog life.
All right, show continues.
The show continues. All right.
Follow us on things.
Yeah, what things do we have, Liz?
Oh, God. Well, we have the one nobody wants to use anymore, Twitter, at Drinking Cosmos there. But you can follow us also at Cosmos the Cosmos on Blue Sky, also Instagram and Spotify and Apple Podcasts and YouTube and the things that are out there in this culture we have.
And on those things, feel free to, give us a rating. If you rate us, more people can listen, and we can spew slightly intelligent nonsense into more people's brains.
Yes, exactly.
I just enjoyed watching Mr. Frodo walk back and forth.
Oh gosh,
It's going to be like that all day.
It's fine. Everybody likes dogs.
Everyone likes dogs. You know what else everybody likes? Katie and Ron.
Yeah, Katie, Ron, and Jack.
So here's a friend of the show that make some really cool stuff. For example, Katie is Wildixia on Etsy. Strong, just checking that out. We have Ron, Mr. Ron Proctor Show.com, who makes the intro music for our Hangover. And of course, if you happen to be in the Rolling Bluffs, Iowa area, check out rollingbluffplanetarium.com, run by Jack.
Yeah.
Likewise, we don't have just the full episodes. We also have little bite-sized episodes, little shot episodes, oddly enough, called The Shots.
Yeah, take a shot of astronomy science every other Wednesday. One just came out recently, and one shall be coming out again.
This Wednesday, I think.
Oh, hold on. Let me look at the calendar.
Never ends.
It doesn't.
I think it's this Wednesday.
It could end if we decide for it to end. 27th. Oh, you know what? Actually, we don't need one until the 11th, so we could not record until next weekend if we wanted to do that.
Let's do that.
Okay. All right.
Okay.
Just because
I got my times like all weird. And I assume also for those listening that we will probably we might have to take a hiatus for the 29th one, but we'll see. Mr. Frodo.
I'm Mr. Frodo.
All right.
You want to help us out here? Okay, so we got some rules today, which will likely come into effect.
Yeah.
Our first rule, anytime a puppy barks, take a drink.
Okay.
I suspect that will happen. Maybe not, because he's getting better about that. Any Star Wars reference, take a drink. Any Lord of the Rings reference, take a drink. And do we have the special rule being enforced?
No, sorry.
No, I don't think we need a special rule.
No special rule for today.
Just, drink it and be merry, everybody.
Because we got enough dog barks that may happen.
And anytime Brandon says, no, sir.
Take a drink.
Okay, well, that's
That'll be
a special rule.
All right.
I like that you say no, sir, like how we say no, sir, no, ma'am.
That's exactly where it came from.
Gotta be polite to the animals.
So I forget exactly why we decided to do this episode. Basically, again,
I know, but this. You had a whole idea.
Watching something, and I got very excited about dark energy because it's cool as shit.
Yeah.
And then in the last episode, we're like, "What's the next episode going to be?" I'm like, well, I don't know if I can really do that. Mike's like, "Commit." So we committed to dark energy, and then things happened, and now we're here. We're ready to go. We got a show.
In my defense, though, it was 3 a.m. where I was. And I wasn't really quite thinking straight.
Well, you know what? We're getting energetically dark today, so that's what's happening.
Nice. That's
energetically dark.
You're gonna have to save some of that for dog barks.
I know. It's good though.
So what I kind of want to do first with this episode, because it's about dark energy and dark matter, it's about knowing more about our universe. Kind of walk through some of the huge moments when we found out we are much smaller than we think we are.
Oh, yes, our insignificance.
Yeah, so for example, we could start with Plato's student Aristotle.
Good old Aristotle. Got a lot of things wrong, but, hey, you got to give him credit for trying.
You do, because there was actually another student of Plato's whose names I can't remember, and as a thought experiment, he looked at the mechanics of the heavens, of the skies, and put them on spheres, just to quickly explain it. He goes, this isn't real. This isn't really how it works, but as a mechanism, if you put the planets on the sphere, put the stars on the sphere, this layer on the sphere, the sun, and everything moves, well, it kind of makes sense. But then Aristotle came and said, no, we don't believe in metaphorics. This is real. These spheres are real objects in our sky. So he put 58 spheres in the sky to move all these objects.
Wow. I mean, we don't believe in metaphorics. I mean, philosophy started with the ancient Greeks. I mean, come on.
So from there, we kind of have a world set, the Aristotle view, which is going to last a while.
Yeah.
The next wasn't really a big one, but Ptolemy comes in a couple hundred years later, and he tidied the 58 spheres into just 46 spheres. It made everything look just a little bit nicer.
It just cleaned it up a little bit. It's got trimmed the excess fat and just, also gave us a lot of, and also cataloged a lot of stars and constellations for us, or mainly constellations, I would say.
No, sir.
Oh,
Take a
cheers.
drink.
Take a drink.
Sorry.
A drink.
He likes to go number 2 on carpets when I'm not watching, and I forgot to close that door. Alright, so we got those 46 spheres, right? And it's pretty much going to stay there for about 1,500 years.
Wow. I mean...
Yeah, they go, yeah, these spheres make sense. Just call it a day. It kind of explained things enough.
Aristotle basically ruled physics until
well, yeah, but also
Galileo
you
came
needed
around.
to have the technological development, i.e. the telescope, to really kind of start to see things in a different way.
Well, yes and also no, because at the same time, you can just use different reason as opposed to literal spheres controlling the sky and think, well, how else might this work? For example, and have these other thoughts.
Yeah, but you kind of had the whole Dark Ages happen and lost a lot of knowledge and things in the church, and then it was pretty ballsy to think about, you know.
Because speaking of ballsy, 1,500 years later, that's when Copernicus came around.
Hey!
And speaking of the church,
right?
Yeah.
So they weren't terribly happy with it, but at the same time, when Copernicus came in and made it a heliocentric solar system as opposed to Earth-centric, everything goes around the Earth, the church, doing some research, wasn't actually too mad about it, because the church was running off of the Julian calendar at the time. And the Julian calendar was created by Julius Caesar, based off the advice of Alexandrian astronomer Sosigenes. And Julius Caesar made this calendar because the solar calendar they were originally on had drifted ahead by real time by 3 months.
Oh, yeah.
So all the sorts of things aren't making sense.
Yeah. Shenanigans.
Yeah. And even the solar calendar, I wanted to wrap it the whole year, started in 237 BC in the infamous decree of Canopus by Ptolemy II of Eucrates, if you were curious.
Oh, it's just made a solar calendar. It's just like, hey, I decree a sun calendar.
I decree calendar. So we had the sun calendar, then we had the Julian calendar, but time drifts quite a bit when you don't have the exact details you need. So the problem to the church was Easter.
Fucking Easter.
Because you gotta know when the dead man rises, right?
Yeah, you gotta know when it's the second full moon, last full moon
month
of the month, and the before spring, and whatever fucking magic.
So when Copernicus came in with this heliocentric model, it actually made some different calculations and allowed the church to fix the calendar in 1582. So they may have been a little mad at first, and they go, "Oh wait, this makes sense. Let's run with it."
Okay, it solved a problem for them. Yeah. You know, somebody did a little. Well, did Copernicus? He didn't use a lot of math, though, right? Did he math a lot? Because Kepler came along later and mapped it all out before, and then Galileo used the eyeballs on it. If he did math, it was
very.
I wonder what Copernicus's motivation was. If he's just bored, or he's just like, you know what, I'm gonna think out. You know what? What a good out of the box thinker. To be like, you know what, we're not at the center.
Yeah, well, I mean, yeah, it makes sense. But then he didn't put it forth until he was on his deathbed.
They always do that, don't they? It's always
He's a little scared of the church, though.
Well, right. Yeah, okay.
I mean, and rightly so.
Yeah,
and this is exactly what you were talking about, Liz. For 1,500 years, no one had the other thought. Very likely somebody else had the other thoughts, but A, can I back it up with observations, and then B, to scare the shit, to shake up the worldview.
Yeah,
so sometimes it takes 1,500 years to get that, next step.
Especially when you got things like the Inquisition.
You had two things. You had Aristotle.
Yeah.
So to come up with a different worldview, you have to go against the church.
You have to go against 1,500 years of history.
You have to go against the church, and you have to go against Aristotle, and these are two big things in scientific whatever in the world. And so I mean, it's tough.
I mean, this is a time when people are basically pooping into holes and then throwing buckets of poop out the window because that's what the sewage is like.
Yeah,
so.
but also keep in mind, this is here in Europe. Shit's going on over in India and China and
Yeah.
Right.
So
I mean, in the Arabic world, they're way more advanced intellectually, I would say, scientifically, so to speak. Jack in chat says his middle schoolers are certain they are the center of the universe, as are all middle schoolers. We were all the center of the universe once, and maybe some of us still are. No, I'm just kidding.
All right, so we have Copernicus, and then we have Galileo come in to really confirm what Copernicus is saying. Yeah. And of course we got...
because he saw shit with his eyes. He made the observational proof.
Yeah, the observation. That doesn't make sense.
You gotta have the mathematical proof and your observational
Mathematical.
proof. Algebraic.
Yeah, so we had more observational proof, math coming in. We have Newton coming in explaining this is gravity. This is why things are attracted to each other. Exactly. And then we had a whole lot, really, of filling in details. Even like Kepler, for example, and Charles Messier. Like, we kind of know how things more or less ish work. Let's actually get the details now and make sure we know.
Fine-tuning. Do a little
fine-tuning, exactly. Yeah. So one of the next big steps takes place a couple hundred years after that in the Great Debates. This was, is the Milky Way all that is, or are there other island universes? Have we done the full episode on that yet?
Yeah.
We have?
Well, I don't know. We've done a full episode on a lot of things, but we've talked about this a lot, I believe.
We can look at the list later.
We probably have like a Hubble.
Yeah, and then during this debate, it turns out that by resolving individual stars in the other nebulae and Andromeda Galaxy, the Milky Way is a single island in an ocean of island universes. So suddenly, we're not just in a solar system, we're not just in the Milky Way, we're just a bead of sand in this ocean.
Yeah, we're just one in 100 million trillion other things.
One in a lot.
But we can at least take solace that when we look up in the sky, everything is eternal and stays the same forever, right?
Always,
that's,
yes.
That's creation. It stays eternal and perfect.
Yes.
Turns out, a couple years after that, Edwin Hubble found redshift in these galaxies, that they are actually racing away from our perspective.
I mean, that's because they all know that humans are here, and they're like, we gotta get the fuck away
out
from
of
these
there.
crazy motherfuckers.
But then when we discovered that, we thought, wait, do we live like in a steady state? Does all matter already exist? Are we in an oscillating universe where things get further away and then comes back together because the gravity brings it back in? We had no idea. So let's leave it there for a second.
Okay.
And we're going to talk about one of our favorite astronomers.
Edwin Hubble.
Vera Rubin.
Vera Rubin.
Never heard of her.
Well, we're going to do some educating today. So Vera Rubin, at this time, she was 22-year-old mother with 9-month-old, and she was giving a master's thesis where she gathered data on 108 galaxies.
God, it's not what I was doing at 22.
Anyway. Yep, okay. That's a rabbit hole right there. So she measured the redshift on those galaxies, how fast the objects are moving away from our perspective, while canceling out the expansion of the universe. So it was like movement in a vacuum. And that's called recessional motion.
That's what our country's doing.
Moving away?
Receding back into the dark ages.
And so as she was finishing this thesis, she was exchanging letters with French astronomer Gerard de Vauclair, who was on Australia at the time. And they were talking about the rotation of these galaxy clusters, superclusters specifically. And so this kind of spurred their thinking. And Vera then compiled data, and 2 years later completed her thesis that was called Fluctuations in the Space Distribution of Galaxies in 1954. So in this paper, Vera concluded the galaxies don't randomly clump together. They clump together, of course, because of gravity.
Yes, gravity, the reason for the season.
Yeah, sure. And so 9 years later, she went down to the AAS, Astronomical Society meeting in Tucson, Arizona. At the time, she wasn't even the full-time astronomer because, as she says, quote, galaxies may be pretty remarkable, but to watch a child from 0 to 2 is just incredible. I'm like, oh, that's nice.
Aww, she's a mom first.
Yeah, but then she also said at the meeting, within the galaxy, everything moves. In the universe, all galaxies are in motion. The Earth has moved 2,500 miles as it orbits the Sun every 2 minutes. The Sun has moved 20,000 miles as it orbits its distant center of the galaxy. In 7 years, the Sun moves 300 billion miles. Yet this vast path is only a tiny arc of a single orbit. It takes 200 million years for the Sun to orbit once about the galaxy. So she's always thinking about the motions of everything within galaxies.
Wow, everything is moving. Like atoms are all vibrating and shit. Everything's moving constantly.
Take that, steady state.
Yeah.
And then
take that, quantum physics.
Oh.
Hey.
Now, think for a moment, the little thought experiment. Put yourself in the Andromeda Galaxy, looking back at the Milky Way.
Okay.
So just like us looking at them, they would see a motionless, massive cluster of stars. But if they looked in the red or blue electromagnetic spectrum, suddenly they'd see the rapid approach of our galaxy coming towards them. And looking at the Andromeda Milky Way, Vera had expected that the objects farther from the center would be moving slower. Kind of like our own solar system, right? A distant planet orbits slower than the inner planet.
Yep.
It's years longer.
Orbit of Neptune, crazy long.
Yeah.
Yeah.
Can't imagine that either.
And then because Vera has actual observations and not just subjection, she discovered that the outermost stars around the Andromeda Galaxy had the same orbit rate as the inner stars. It's like Neptune having the same length of the year as Mercury.
That would be weird. Something wacky's going on.
Something wacky.
And I think I know what it is.
It confuses me.
Aliens.
That's what it is, aliens.
It's aliens.
And so, during this time, Morton Roberts from the National Radio Astronomy Observatory in Virginia met with Vera and a few other astronomers in the basement. Like it was some kind of secret meeting, and they met in the basement.
Well, astronomers do it in the dark.
In the dark.
And
yeah,
damp,
right.
I guess, in the cold.
So Morton Roberts was studying the center of galaxies in radio wavelengths and the rotation curve of the Andromeda Galaxy. So it was in this deep, dark basement that Morton put a visual copy of the Andromeda on the table and then transposed it on top with a copy of the galaxy in radio wavelengths. And they found that the velocity of these billions of stars didn't match up with each other. So as Morton said, What is the mass out there? What's the matter? There's got to be matter out there.
What's the matter?
What's the matter?
What's the matter with you?
So it was the Andromeda Galaxy, as we see visually, but in the other frequencies, it wasn't because it was moving faster than we had expected. So now we're going to move a little bit. We're going to move to Mr. George Peebles, which is a fun name.
That's a fun name. Peebles. I also, just to go back, the name Morton.
Morton.
That's
a very...
Salt. It's not a name you hear, Morton. Okay, back to Peebles. Peebies.
Mr. Peebles. He was a Canadian citizen working at Los Alamos in the 1960s.
Oh, that's...
Of course, with the nuclear research
fun.
there. But his colleagues considered his work too esoteric, cosmology basically, so they didn't really pay attention to what the hell he was doing. So he could do what he wanted to do, which is kind of nice.
You would think like physicists and astronomers would be more open to like, weird
things. Kind of through this time, cosmology was almost looked down upon because you couldn't really study it. There's no way to confirm findings. It was, what do you think is happening out there? So it was just more
metaphors here.
Yeah, it was more philosophy. And I don't think it was Peebles. It was another, I think, another one, we'll get to in a moment, who had to choose between physics and philosophy and decided that he wanted to focus on physics because in science, he still asked the big philosophical questions. He just got out to find the answers to them.
Ah, okay. I like that.
That's kind of a good way of putting it.
Physics, the philosophy of astronomy.
Mm-hmm.
Kind of.
So, Mr. Peebles. In Los Alamos in the 1960s, he was running n-body simulations, which is just basically taking X amount of objects in space, putting them together, and just seeing how they interact.
See what happens?
Yeah, see what happens.
Oh, it's like the real world.
We need an MTV for science. We just put things together and see how they react. That's called chemistry. So Peebles took these millions of calculated bodies and had them act like they were a galaxy cluster. The smaller galaxies went towards the bigger galaxies, and they clumped.
Of course, gravity.
Right, so with this, he went to Robert Dicke. Does that name sound familiar, Liz?
Good old Dick. No?
Good old Dick. So Robert Dicke, also famous with the Arnold Penzias and Robert Wilson for the cosmic microwave background.
The horn.
Yes. And actually, this is roughly the same time where he was scooped by Arnold Penzias and Robert Wilson when Peebles met with Robert Dicke. And they put together a paper called Gravitation and Space Science. And in this paper, they state that one can no longer see island universes as individual galaxies. They are all interconnected because they're clusters as a sum of their galaxies.
Okay.
Okay, so he calls it the unity of the universe.
They need to workshop that a little bit.
All right, so we got Peebles doing this thing now. He's realizing that these galaxies aren't just, by themselves. Everything is interrelated. And this is when Jeremiah Ostreicher comes in. He works with Peebles, and they conduct a simulation. Jeremiah Ostreicher.
Yeah, that's the name right there.
It's a bullfrog.
So they conduct another simulation, this time of the Milky Way galaxy, using that same n-body strategy. And they find out, with everything they see, all the mass of the stars, the galaxy is torn apart within 200 million years.
Ooh. That seems like a fast time scale.
Yeah.
Well,
So,
it turns out they're missing a lot. He says
Yeah.
there's something wrong here.
Yeah.
Which is exactly what, or extremely similar to what one CwC saw in 1933, looking at the Coma Cluster. What did he see looking at the Coma Cluster, Mike?
dark matter.
Hey.
Yeah.
Wildixia, also the name of our Xbox.
He saw galaxies moving faster than they should, and so there must be
There's something else.
some unseen matter that's making
Because you
them
got to
move
have more
faster.
gravity than what the visible matter is presenting.
Yeah, so he was the first to come up with dark matter.
Yeah.
He mattered.
He came up with it, of course, and then
I said he mattered.
Yeah.
And then Bear, Rubin, Peebles, Ostraker, the simulations came together and concluded there are reasons increasing in number and quantity to believe that the masses of ordinary galaxies may have been underestimated by a factor of 10 or more.
That's a lot. That's a big discrepancy.
That's
We
true.
call that the Rubin-Ford effect. And so CwC coined the term dark matter, and Rubin came in and really put the scientific observations and calculations behind it, saying this is real, dark matter exists. Look at all this evidence.
A woman supporting the boys. Yep.
And then never got a Nobel Prize.
No.
No.
Gypped, robbed.
But there's a really cool telescope coming up.
There is the Vera Rubin telescope observatory in
It's active, right?
Yeah, I think it is.
Where is it? Is it in Chile? Where is it?
So.
Where is it?
I don't
Where
recall.
is it? Somebody, Jack. It's less of where it is. I can't remember where it is. That's gonna be really exciting when that gets.
Yeah.
When does that come online? Do we know?
It's already online, I think.
Oh, it's already online? Okay, I thought it was still under construction.
So it turns out we were missing a huge chunk of the universe. We don't know what it is.
And we
call
can't
it
see
dark
it.
matter. Yeah, so that was another big step forward, just like
Yes.
Aristotle with the spheres, Copernicus. And so now with that dark matter in our pockets, let's fast forward to the 1980s. So once again, science is trying to answer those philosophical questions. For example, now that we have the matter of the universe known, will the universe have enough matter to slow down expansion and eventually reverse itself? Does the universe not contain enough matter and expansion will just continue on forever until, just goes away? Or is it like Goldilocks, where there's just enough matter to hold it in a place at a certain point? So,
what's the matter? I would just like to, since you mentioned Goldilocks, I would just like to do a quick plug for the newest Puss in Boots movie.
really?
Very fun, actually. Very fun. Enjoyable as an adult. Enjoyed
All
it.
right.
So we watched that last night with Katie. So.
oh, fun. So speaking of Goldilocks, those three scenarios are referred to as the Big Crunch, the Big Chill,
Yes.
or the Goldilocks universe.
I mean, I won't say the spoilers on what we'll get into it, but what would be your favorite to happen if you could choose any three of those?
Well, the Big Crunch, because then you would reverberate back and oscillate, would be a series of Big Bangs after Big Bangs after Big Bangs, which would be fun.
Yeah. I like that.
But
I like the Big Crunch.
There is something romantic as well of the universe just moving away slowly, and ending in a chill. In fact, speaking of which, I saw a statistic from, it wasn't Amy Hill, I forget who it was, but 95% of all the stars that will ever exist have already been born.
Yes, I remember hearing that. That's wild. Also, I would like to say that is what, if the statistic is still there, the 50% of marriages end in the Big Chill.
Oh, nice.
Right. This is the most bizarre episode.
It's
For
on
someone-
dark energy.
I know, but
Eventually.
but my brain is still in like a cold fog.
Oh
and
yeah,
it's just
because he's been sick
It's
after the
just-
travels. Okay, Ruben is
bizarre
in.
episode.
Jack says Ruben is in Atacama, Chile. The
Ooh,
camera
nice.
test was October 28th.
Oh,
of this
just
year.
nice.
I thought it was in Atacama because that's like one of the most ideal telescope places.
Okay,
I'm moving.
so
Moving to the Atacama Desert in
Yeah.
Chile, it's gonna be a
that'd be
little
nice.
chilly.
Oh my God.
Man, Liz coming in with the dry humor. Hey.
Man, this is
Okay.
I'm just gonna do a little drink for the combo.
Yeah, that was well done.
Tag team.
Well done, team.
comedy desert.
All right, so it's the 1980s.
It's the 1980s. I'm coming around, everybody. I'm about to come online at some point.
We're trying to learn, how will the universe end ultimately, right? We know the Big Bang. We know that the universe is moving away from itself, but how will it end? So it became one of the basic conundrums in just science or cosmology in general. So matter
also
attracts...
not a thing we necessarily need to worry about, but why not?
If you want to know things,
yeah,
sure. Esoteric knowledge is nice. But also, what is dark energy? What is dark matter? I want to know. So matter attracts matter, thanks to gravity, right?
Yes.
And the universe has a lot of gravity. Nicely done. And so then why are these galaxies rushing away from each other and not collapsing?
Exactly.
And so there are some people in history that thought about this. For example, Isaac Newton thought about this problem. But he found a solution. He figured it out before anyone else did.
Did he? What did Newt's figure out?
He said, in quotes, "And so that the systems of the fixed stars will not fall upon one another as a result of gravity, he, being God, has placed them at immense distances from one another."
I'd be true, but not true, but true that there are immense distances. Not true is the God part, but...
Another fellow, Albert Einstein, saw this as a problem too, and he famously added the lambda to his general relativity.
His greatest blunder. Check out our shot! Einstein's greatest blunder, out now on YouTube and Spotify.
Nice.
And elsewhere.
And that was, of course, just a way to keep the universe intact, but then, of course, we discovered expansion, and it worked out. So to answer the basic question, we needed a way to reliably measure the expansion of the universe. This is where our old friend Type 1a supernovae come around.
Hey, big booms.
Hey, Liz, what's a Type 1a supernova?
It's when a star basically can't maintain a hydrostatic equilibrium anymore because it gets to making iron and iron. Am I talking about type 2s?
You're talking about type 2.
I like the big boom ones. With the type 1 is when you
dwarfs.
already have the white dwarf and then it collects extra matter. It's
usually
in a binary system and it collects matter from its partner, and then it gets too much matter to the point where it basically just booms off the surface of it. It has a big boom that happens, and it does a little. It does like it's the white dwarf supernovas basically. Is it left intact or is it destroyed?
I don't know the answer to that question. Because you do have like reoccurring type 1.
Yeah, so maybe just like the outer layers booming, and then
it looks like sometimes it's just destroyed, and so I don't know. And what does that mean for the partner?
Maybe we need an episode specifically on type 2 supernovas.
That's a good idea.
We got some. It's not the biggest boom, but it's
still a very big boom. Big, and this big bada boom. The idea was to use it as a candle, a type of standard candle.
Standard candles, yes.
Where one event consistent across space and time could be used as a measuring stick. It's just kind of the same relative brightness, regardless of location. Yeah. So if it goes up way over there, you know how bright it should.
It's the same physics, basically. Yeah. So
in the 80s, the Supernova Cosmology Project, which sounds like a really cool band name, based in Chile, began in 1985 to disprove that Type 1a could be used as standard candles, because they had to make sure, right? We think this could be used as standard candle, but we need to make sure.
Okay, all right. Okay, usually science doesn't go to disprove stuff.
There were some people trying to prove it. They wanted some other people to try to disprove it at the same time. Okay. Sure. And it so happens that astrophotography was advanced enough with these newfangled CCD technology in the cameras.
Telescopes.
Hey. So with these new telescopes and this team, they found more and more of these Type 1a supernovae. And in 1987, actually, we had a very close supernova. 1987A in the Large Magellan Galaxy. But that was a Type 2 supernova. So on this team in 1992, Mark Phillips was in Chile, and he gathered the light curves of 9 Type 1a supernovae and discovered a correlation in the brightness of the explosion and how quickly it dims.
Oh, okay.
So they went out trying to disprove it, and we found out, nope, there's a correlation between brightness and dimming and where it's at. So they had found the standard candle, and now it was possible to discern the expansion of Hubble constants. Plus, there's another nice little tool in their pocket, the Hubble Space Telescope.
Hey, good old Hubs.
There's Hubby
Yay!
Hubs. And of course, having a high resolution of telescopes makes supernovae really stand out in the galaxy, so you can really pinpoint them. So just 2 years after that, they discovered the standard candles, another team started out in Berkeley, the High Z Supernova Search Team in 1994.
High Z.
So these teams began hunting down supernovae and measuring the standard candle redshift for distance and how fast the way is moving, because they wanted to figure out, how much was the universe decelerating in its expansion.
Ah, okay.
Which, yeah, makes sense, because, yeah, it just makes logical sense.
It's expanding, so, it should be, naturally you accelerate and then slow down.
Yeah. And so on September 24th, 1997, Gerson Goldhaber with the Cosmology Project team.
Man, what a name.
Gerson Goldhaber.
Goldhaber.
It may be Goldhaber.
Gerson.
I just went with it.
But also Gerson. It's the GG.
GG. Oh, there's the OGGG.
OGGG.
So the OGGG was a chart that distributes numbers in neat little categories. So Goldhaber found that over half of the supernova samples, 39 in total, were wrong. It showed that there simply wasn't enough matter to explain how much they were redshift.
Oh.
But he found out to explain these samples, to explain these numbers, the deceleration of the universe had to be negative.
Okay.
Wait.
Okay.
So it's not decelerating.
It's not
it's
decelerating.
Accelerating.
Oh, okay. That's what that means.
And at the same time, Adam Rees of the High Z team found the only explanation for their own independent findings was that the universe had a mass density of negative 36%, which means things. So both the High Z team and the Cosmology Project, we'll get there, working off the belief that the universe was made entirely of matter that we know of. Sure, there's some dark matter, but it still operates like matter. But these findings show that upwards of 80% of the universe was something else.
Ooh, aliens.
Aliens, of course.
Wait, I have a quick question that nobody can answer. Maybe Mike can. I don't know. Okay, so you have the Big Bang, and you have this rapid expansion from nothing. No bang involved, misnomer, but you have this rapid expansion of the universe. Now, according to, the laws of what gravity or whatever it is, an object in motion, stay in motion. Inertia, so there's nothing hindering the universe from expanding, so then why would we think it would decelerate? Because just from an energy loss perspective, I guess?
Entropy, right? Like, over time, you just, right?
I thought that's just when you clean a room and then it still gets dirty again. You just gotta keep cleaning it until you die, and you don't have to clean anything anymore.
Well, mass and space-time are related to each other, and so they both have an effect on each other. And so if you have enough mass, it's going to slow things down.
So that is the opposite reaction to the inertia. Anyway, moving on.
Okay.
Yeah, so
that is the object in motion stays in motion unless acted upon by an outside force, and that extra mass, that mass is the outside force that...
But if all these galaxies have mass as well, a significant amount of mass, then they should be slowing down the other objects rushing away from them.
But also, all right, so Big Bang happens, matter goes out, the universe is expanding, and as the universe expands, it takes these galaxies with it. And so the question is there enough mass in the universe? This is before dark energy. Enough mass in the universe to stop the galaxies moving with the expansion of the universe, and then kind of collapse down.
Right, okay, the mass of the galaxies
and that is
attract
the big
each other,
crunch.
and that is what they're thinking. Okay,
and then you also have the situation where everything is kind of in balance, where Big Bang happens, galaxies go out, the expansion of the universe takes them with it, and eventually, if you had infinite amount of time, basically the galaxies would, the mass is pulling them in, but the expansion is taking them out, but it's equally balanced, so the galaxies just at an infinite time scale would not move. So they would stop, and then of course you have the big rip where they just keep going faster and faster and faster. Big chill, really, is what it is.
Isn't time already infinite?
What?
No.
Okay, continue
We have
on.
a whole episode on that. Go see our episode.
Go check our episode.
All right, so with that told teams that A, the universe would not collapse in on itself, and B, that the universe isn't decelerating at all; it's in fact accelerating.
Accelerating.
And then C, what the fuck is going on?
I like C is the answer to everything. It's just like what the fuck is happening?
So the teams, they coined the term dark energy.
Of course.
To explain this, as a tie into dark matter, the two aethers that dominate the cosmos. But again, we have no idea what the fuck's going on. Of course, today we know what dark energy is. And Mike, if you want to explain that to the people, that'd be great.
Wait a minute. You said we do know what it is?
Yeah, and if you could explain to the people.
In a joking sense.
Oh,
because we don't know.
We have absolutely no
fucking
idea
know what the majority of our universe is made up of, basically.
We have ideas.
We don't know what dark matter is. We don't know what dark energy is yet.
Yeah, we have thoughts.
Yet. How can we figure it out?
Well, you had to look at the massive scale of all the galaxies, which is why it's so difficult getting observations of dark energy, because it's difficult to get those kinds of massive observations on the cosmologically wide scale. But hopefully the Vera Rubin telescope. Got a bigger telescope. Hopefully that Vera Rubin helps.
But with interferometry, I mean, we could make a but I guess it's not in the wavelength that we need for because most interferometry is done with radio telescopes, because those you can are
interferometry to get
is
dark
radio.
Energy.
Yeah.
Well, I think at this point we know it's there.
We know it's we know it's out
there. So I think at this point it is trying to understand what it is, and there's a couple of ideas as to what it might be. One of them would be, and the one that's generally accepted is not
acknowledged
or believed in or whatever is the vacuum energy. So if you have
Frodo would hate that.
It's from like a Dyson or...
I know. So if you have a cubic meter of space, and for Americans out there, it's about 3 feet 4 inches.
I just picture like a yardstick, like is that a meter stick? A yardstick? Is that a?
It's a little more than a yardstick. It's 3 inches more than a yardstick. So you have this cubic meter of space, and you take out all the matter. You take out all the atoms.
Okay.
You take out any electrons that might be zipping through, cosmic rays, that type of thing. Now, take out all the photons. So all the energy, all the light going through it. Just remove it all. And so this cubic meter of space has, quote unquote, nothing in it. But that's not true.
Box.
Because of, quantum fields oscillating and stuff, you actually have these virtual particles that pop in and out of existence. And so what they do is they pop into existence, and then they survive for basically an extremely short amount of time, like a Planck length of time, and they come back together, annihilate, and return that energy back to the universe. Okay, so all this fluctuations in energy, this vacuum energy, is what they think is responsible for the dark energy expansion of the universe. All right, case closed. Move on to the next thing. Yeah. However, when you do the calculations for like in quantum mechanics of the vacuum energy for that 1 cubic meter. The amount of energy, the dark energy, if you could take the dark energy from that cubic meter that we know about, and basically using E equals mc squared, turning into like a mass, it turns out that it's about the mass of a grain of sand here on Earth. So extremely small amount of energy. But when you do the quantum calculations for it, it is off by an order of 120, a magnitude of 120. Oh. So it is way off.
So the math doesn't line up.
The math does not
line up. What if our math
up.
Is wrong? What if there's more other particles than we know about?
Massive difference. And so there's something going on with that. Maybe we don't understand vacuum energy like we thought we did. Another idea is quintessence, which is a which is a you have like the magnetic field that permeates the universe, right? And so this would be kind of like that. Dark energy field, this quintessence field that permeates the universe and is responsible for dark energy. Right now, like quintessence has some things that look really promising and great about it. Basically,
first of all, vacuum its name.
Energy.
That's the way to go.
What's that?
So first of all, the name of it.
Yeah, the vacuum energy is the cosmological constant at lambda that Brandon talked about, that Einstein had thrown into his equation.
Is it a sacrificial lambda?
Nice.
Huh? What?
I said, is it a sacrificial lambda?
Yeah. And so it's we don't know. And
half of what you said just made half my brain melt. So
now, do you think the people that eventually receive the Nobel Prize for this discovery, do you think they are alive yet?
I think so. I'm
gonna go with no.
We got a yes and a no.
I think we need more because I don't know what we need, honestly.
I think we will figure it out within our lifetime.
Really?
Yeah.
Better hurry up, guys.
What does that mean?
We're dying soon. It's look, it's only like a month away from January, so
I that might be optimistic, but I do think that that we'll figure it out. Do I think we're gonna get a theory of everything in my lifetime? No, I don't think that. But I do think that we might figure out dark matter, dark energy. We have all these telescopes and stuff that are coming online. Vera Rubin, the Nancy Grace Roman telescope. You got James Webb. Hubble's still kicking. And so you have all these things that are feeding in.
Would it help at all if we could get the world to cooperate together, humanity cooperate together and build a collider around the circumference of the Earth?
I've seen that movie.
Really cool.
I've seen Contact.
That would be really cool. But speaking of that, one of the problems with quintessence is that it would have a particle associated with it, and they're just not seeing it.
They're not seeing any kind of particle. But the particles can be elusive. I mean, it took how long to finally discover the Higgs boson?
That goddamn particle.
It's true. That is true. But, the thing is like...
what if it's ghosts?
Quintessence,
what if dark energy is ghosts from everything that ever lived in the universe?
I have another thing that's going to confuse me on this.
Oh, gosh, yeah.
Right.
Okay.
So we know that dark energy makes up about 70% of the universe. However, it started to dominate the universe relatively recently, only 5 billion years ago.
Oh,
so 5 billion years ago, the repulsive gravity of dark energy then overwhelmed the attractive gravity of dark matter.
Well, they were equal.
Oh, they were equal? Okay.
Well, yeah. Well, 5 billion years ago.
They were equal.
And then at that point,
yes.
as it expanded, dark energy became more
so the
dominant.
expansion of the universe apparently was at one point slowing down, but since dark energy overwhelmed dark matter, it's now speeding up.
So what happened 5 billion years ago in the universe to cause
the universe expanded to a point.
Physics. Right. Weird physics happened.
What? No, maybe it was a multi-galactic war.
All right, well, here's the science explanation for it.
In another galaxy, a long, long time ago, in a galaxy far, far away.
So dark energy doesn't, in that 1 cubic meter, there's not a lot of dark energy, right? Uh-huh. However, though, that's just 1 cubic meter. There's a lot of cubic meters.
How many?
Wait.
In the universe.
How many?
That means we have the dark energy in us right now. We have the dark energy, Liz.
You do have the dark energy.
Oh, we have the dark energy.
Jack's disappointed that, so disappointed in Equatorial Ring and no one mentioned Stargate. No, we didn't mention.
He's about to be more disappointed because I've never watched it.
You've never seen Stargate?
No. I know. I saw the movie.
Oh, well then, yeah, no.
Okay, I thought I was talking about the...
No, I was talking about the movie. The movie, yeah, the series, fine, but the movie is what...
Okay.
God, phew. Okay, yeah, we had to watch How to Train Your Dragon last night because Adam never saw How to Train Your Dragon.
Oh, I love How to Train Your Dragon.
No, they're making a live action? Okay,
And
anyway.
the second one makes you cry every time.
Oh, God, okay.
Hangover, guys.
All right. Well, I got a hangover discussion.
All right, so... Yeah, I don't... Dark energy confuses me.
Well, yeah, because we don't... it all confuses me because my brain can only go so far. I think so far outside of a box that of the universe that we live in. But, I mean, yeah, it's one of those things that we don't... I mean, just even trying to explain what it could be, it's like, what?
I just like the story of how we got there.
Yeah.
It is fun. It is interesting to look at the evolution of technological advancement and human thought throughout history that has led us to the various things that we've been able to discover and know about the universe today. I mean, imagine if nobody thought outside the box. If nobody thought about any bigger questions and everybody was just like
1 meter by 1 meter box.
Yeah, like it was just like, yeah, sure. It's just we gotta do. Well,
if it's an alternate dimension that gives us the energy that the things are popping in and out of.
How's string theory coming along? Any progress with that?
I'm sure it's coming along.
Oh, there's a fun. Is it a short story or a novel? I think it's Asimov. The Gods Themselves. It's about energy source that somebody discovers, but what they're actually doing is stealing basically the power of a different star in a different universe, and it's making their star weaker and weaker and weaker. Yeah, that is pretty cool.
Wow. I feel like that really, really we don't know half of the things that we think we know about. I like half of you as much.
Yep, there it is.
That's
quote. What I was waiting for.
That's the quote I'm going for. That's the. You know, like it's taken us how many hundreds of thousands of years of human existence to get to this point, but yet we still, I think, don't really understand anything.
But at least now we know that we don't know, right? It's like, hey, we have 46 spheres. Call it a day. That's all that is.
Imagine if everybody on Earth cared about like astronomy like we do. Think of the advancement. And it's not just like throwing like cars into space and shit. Like it's actual like discovery and actual science and understanding the world. Imagine if everybody felt like that was the most important thing.
So like a Star Trek universe.
God, can we have a Star Trek
remember,
universe?
Star Trek went through some shit before they got Star Trek. So
we're doing that. Okay, can we just skip ahead?
We got the Bell riots coming up a month ago. That's when that started.
Can we just get somebody? Okay, is anybody working on replicators? Is anybody working on replicators, first of all? Can we... Do we know enough about matter to do replicators?
All right, so we are gathering steam to the hangover portion of this episode now, talking about replicators.
So the answer is dark energy. We don't know what it is, but it's happening, and the universe expanding because of it, but we're still trying to figure it out. But we got some new telescopes about to come online that will help us in that discovery, but stay tuned for more on the universe.
This has been Cosmos with Cosmos. Follow us on all the things. Hang out for the hangover if you're here. Bye.
Cheers.
Bye. Thanks for joining us. If you're with us now, Jack, thank you. We'll be right back after these. No commercial breaks. We don't have commercial breaks. We'll just be right back. Be right back. The Hangover. Welcome.
Welcome back to The Hangover for season 6, episode 6. Dark energy, dark matter, and things that make us feel small. Today we're here with Mike George and Liz Davison. Welcome to the Hangover.
Thank you for having us, Brandon.
Yeah. So in your recent book, Liz, you had talked about. I don't want the threads being lost.
Imagine if I had written a book.
Oh, you'd write a great book.
If I wrote a book, it would definitely be like a horror story. In fact, I had wrote. Okay, and I think I had written. This is why I don't write a book. I've told this story before to somebody. I don't know, but in 8th grade, I had a. Oh yeah, Katie's back from the store. Welcome back. He's back. Hangover. I had to write like. We had to write like a scary story essay or something in 8th grade, or I don't know, but I wrote.
And you were like, math homework.
I was so excited about this because I was like, finally, all my horror movie knowledge and training can come into play, and I just went full on into the story. I don't remember what the story was about, but I remember using words like disembowelment.
Damn.
And I didn't get that good of a grade on it, and I was really disappointed because I was like, I put everything into the story. Same
was
thing.
Was it more of a gore movie or a horror film?
It was like a gory horror story.
Okay, but that's what they asked for.
I might also be confusing it with when I also got to write a paper on the Titanic. Well, I chose the Titanic as my topic because I could.
That doesn't sound like you.
And I did the paper on like the differences between like the classes on the ship, like 3rd class and second class and 1st class and everything. And I was very proud of it and excited about it. And I think I got like a C on it, and I was very
Jesus
upset by that. And but redemption arc when I was in junior college, community college, some people call it as well, in Arizona, and I took a history class, and my first essay that I had to write in my history class, which I was on World War II, and I did it on Emperor Hirohito in Japan, and I got an A, and she singled it out in front of the class as being an amazing essay, and from that day on, I was like, I will get A's in everything, and I didn't want to disappoint that teacher or any other teacher ever again, and that turned me around as a student in school to do well.
And you know what? That story, it's an A+.
Yeah. Fuck yeah. Anyway.
This is why teachers, they can
make or break people.
They can make or break people.
Let me tell you, that little bit of encouragement from that one teacher telling me that I did a good job when I was like, I don't know, I'm not good at writing or whatever, just spurned me on to
greater heights.
Yeah, but then I got 1 B at one class in community college, and it still fucks me up to this day. Like, I graduated ASU with like a 3.98 because of the one fucking B that transferred over, and I'm so mad about it. I still graduated summa cum laude, and I graduated, much longer after I should have graduated college, but whatever.
I got a C in ASU 101.
Because you thought,
No, because I remember I refused to do the scavenger hunt on the main campus when I'm on the west campus. Like, no, I'm not doing your fucking game. I'm not wasting an entire day to do a scavenger hunt. And so I got a C.
I don't think I had to do that because I transferred from community college.
Yeah.
Main campus is the worst. I'm not a college campus person. When I had to take my classes at the main campus, it was a nightmare. dodging pamphlets from every fucking side of things and longboards and bicycles, and I was like, fuck this. The West Campus is so much more quieter, and there's like nobody here, but apparently Brandon, who I ran into at the bookstore.
Not by choice.
Not by choice.
Not by choice. Neither of us wanted that to happen.
And look at us now!
Hey!
Okay, so I did have a very off-topic thing for the Hangover. Brandon, you've already been posited this question. Mike's been posited this question. This was brought to us by Katie and Adam's friend group, which I dislike them for now.
I don't remember what this is.
You will know what this is as soon as I say it. Everybody, poll out there, chime in. Shrek, cult classic? No, absolutely not. Right.
So Shrek took in $238 million in the box office.
That's popularity.
In no sense is that a cult classic. A cult classic is like Rocky Picture, makes $68 in the box office and stays strong for decades after the fact.
Thank you.
It gains popularity. Yes.
Thank you. It's like
Shrek
niche.
has always been the pinnacle of culture.
Yes,
from day one.
It is a classic.
It is. I remember seeing it in theaters.
I think I saw it in theaters. I don't know. I don't remember, but
because classic. Shrek, as I have my wine bottle in my hand, Shrek. I like it. Was the first time you had moving commercials before the movie began, and even then, I hated it.
Was it really? Was that when they started doing the?
That's when I noticed it, and I hated it.
Oh. Anyway.
So is that friend group of the mind that's a cult classic?
Well, they were his friends were they were doing a Shrek marathon, and I guess one posited to the other, is Shrek a cult classic, and then they had an argument, and then it spawned to.
How old are these people? These people like 15 years old?
They're younger. No, they're your age.
So they should know better.
They shouldn't. I'm assuming they're your age because they're Adam's age. I'm assuming they're Adam's age and Katie's age. Yeah. So they should know better. They should know what a cult classic is. Shrek is a classic. A cult classic is your Rocky Horror Picture Shows.
Yeah.
The ones that don't perform well but have like this niche subgenre popularity.
Or the Toxic Avenger.
Toxic Avenger, exactly. Mid-30s. Yeah. So your age is.
Yeah.
You regular millennials.
No, we are peak millennials, please.
How? No,
because you don't get more millennial than us.
Well, okay.
We're it.
Actually, yeah, that's probably true.
Geriatric.
Oh.
I'm a young Gen Z, so what's that make you?
Geriatric.
Yeah, I was floored by this.
Wait, you're a young Gen Z? No, what?
I'm a young Gen X. Sorry, did I say Gen Z? God,
I thought you were a geriatric millennial.
I'm a geriatric millennial, but I'm borderline Gen X. So
that's not as fun.
No, the cult classic doesn't have anything to do with age of the movie, Adam. It has to do with it not being popular in the mainstream, but having this other subculture popularity and then resurgence into the popular culture.
I have a movie in my mind that was made in the 2000s, but I'm going to make sure that this. Fight Club is a cult classic technically because it didn't have great accolades when it came out. But also, let's find out.
I didn't know Fight Club didn't do well in the box office. It's just, to me, it's always been Fight Club.
So, you're like, Star Wars would not be a cult classic?
No, it's way too, has always been way too popular.
Star Trek movies would not be a cult classic.
Star Trek is popular.
Yeah. Princess Bride?
Oh, Princess Bride, maybe.
Office Space. Office Space is a great cult classic. It bombed in the box office, but it's great now.
Okay, all right. I'll accept that. Office Space. Do you have my staple?
Fun fact about that. At the time, what company was that made the stapler? I don't remember. Fender? Something like that?
Not Fender. Fender makes guitars.
No, but anyway.
String line? Something line? Something line.
But in any case, when the movie came out, they did not make red staplers. Fun fact.
Really interesting. Well, yeah, there was a cult classic is like doesn't do well, but has this niche popularity, and then swing line. Thank you, Adam. But it comes back in popularity for like a short time, and then it goes back into
So for example, James Bond movies are not cult films, but chainsaw movies are.
Okay.
Which makes sense.
Oh, also, probably Spinal Tap.
Yeah,
Spinal Tap would be a cult classic. Yeah,
cult classic.
Monty Python and
Holy Grail.
Yeah.
I don't know because it's British, so.
Yeah. But...
Also, Monty Python was huge at the time, so.
Yeah, I don't think. I think Monty Python is just like classic legend. I mean, it's Monty Python. Like, there's too much
classic
gravitas.
Legends.
It's too much like gravitas to Monty Python. I think.
But long story short, Shrek is by no stretch of the imagination.
Elvira, yeah. A lot of horror type genres are cult classics, I gotta say.
Yeah.
I'm trying to think of like anything like that is like more recent.
Recent. Okay, recent.
I would even posit maybe the original Buffy the Vampire Slayer movie could be a cult.
I can go with that. Oh, a cult classic for us millennials. Zach Braff, Natalie Portman. Oh, it's right there. It's right there.
Braff, Natalie Portman.
Monty Python and the Holy Grail worldwide made $2.8 million.
Yeah, so not
Garden State. Probably
Garden State. What movie
yes.
is
See?
that?
Yeah. It's a cult classic for millennials.
Okay.
You won't understand as a geriatric millennial.
Yeah, I'm too.
Swamp Thing.
Swamp Thing's just Swamp Thing.
Yeah.
I don't know.
Maybe the thing.
I mean, that's a classic horror movie. Like Friday the 13th, and those are classic horror movies. You know. I'm trying to think. Yeah, anyway, Shrek not a cult classic. It's just a classic. It's just Shrek. No. It has a whole empire built around it. Like Star Wars has a whole empire built around it.
I was trying to find a way to tie in cult classics with astronomy. I can't, unless like some cult classic constellations or asterisms out there.
I don't know. Would fuck, I just had it in my head. And now I can't think of what I was just thinking about as a cult classic. I lost it. You said astronomy, and then it kind of came. Oh! Would Neverending Story be a cult classic?
Probably.
It did not do well. Ooh, Spaceball. I don't know. I don't think Spaceball is a cult classic.
Spaceballs is on the edge there.
Because it's a parody. Like. It's a parody, and I think it's always been a popular parody to Star Wars. So I don't know if it would be a cult classic.
Okay.
A cult classic has a specific like fan base and following, like.
Right, but does parody factor into that?
Like Galaxy Quest almost. Galaxy Quest did not do well in the box office, but it has a resurgence now decades later.
So, yeah, I could see Galaxy Quest maybe being a cult classic.
Well,
it is kind of.
I mean, you said Spaceballs being a parody. Galaxy Quest is a parody.
Yeah, but Spaceballs
really.
is like too, I think, popular to be a cult classic because
and Galaxy Quest, yes, it is a parody, but at the same time, it's its own thing.
But yeah, I mean, it's like it's not a great movie, but it's a great movie.
Whoa! When's the last time you watched? When's the last time you watched it? Because it's honestly a great Trek movie.
No, it's a great movie. I'm saying it's not a great movie, but it's a great movie.
Say that again, but slower, and tell me if that makes sense.
Like it's not. It's like it's a cheesy, kind of a lower budget movie, but it's a great movie. Like it's a fun movie. Like it's a good movie. It's well done.
You don't need to add things in front of it. It's a great movie. You just say it's a great movie. Thank you.
But I would say in the mainstream world, it was probably like a crappy movie.
Spaceballs made $38 million at the box office. And
in real money.
Okay. Jack says he went with that because it got its wheels on TV as a cheap movie to license.
Spaceballs, the licensing.
There's gonna be Spaceballs 2, which I believe I brought up on a previous episode that Josh Gad is in and doing or spearheaded as well. And Mel Brooks is in on it now.
I desperately want the title to be Spaceballs 3, The Search for Spaceballs 2.
That would be great. That would be good. I'm excited for Spaceballs 2 because they got to do it.
Me too.
I think they'll do it. Mel Brooks just has to keep on living. Keep living, Mel Brooks, because he's like, what, 90 something?
I think he's got 100. Does he have that in his belt?
No.
He's older than David Attenborough.
Really?
How old's David Attenborough? 93?
Yeah.
No, wait. Shatner's was 93, right?
God.
Mel Brooks. You guys keep talking.
Well, you're right there.
No, we need to know.
You're right. In 1926?
He's 98.
98!
God damn.
98. Come on, Mel Brooks.
Mr. Frodo.
You can do it.
Good boy.
David
thanks,
Attenborough
Jack.
also.
Enjoy your leftover party. David Attenborough. Okay, so David Attenborough and
David Attenborough, born May 8th, 1926.
God damn.
Oh.
Mel Brooks, June 28th, 1926. So
I am so looking forward to the day in the future when I'm talking to some kid and they go, "Whoa, hi Frodo, you were born in the 1900s?" Yes, Sonny, I was.
Why are you looking forward to that day? Well, although when that day does come, then you're old enough where you can just claim dementia and do whatever you want.
Yeah, 5 years from now.
only it was now.
Is there going to be a world in 5 years?
Hi, buddy. Oh, yeah, there'll be a world.
Yeah, there'll be a world. Is the U.S. on the axis of evil?
With us in it
No.
in 5 years.
So anyway, I
right.
really want a house I
See
saw.
you later, Jack.
Oh,
have fun at the.
Oh, I already said
leftover
bye
party.
to him.
Huh?
I already said bye to him.
Oh, well.
He's gone now, I'm sure.
Okay.
Leftover. We have a lot of leftovers.
Same. Hey, Mr. Frodo.
Are we getting a pizza tonight?
Oh, I thought we were just gonna eat leftovers.
Are we gonna make hamburgers tonight?
We don't have any hamburger material.
But you have pizza, so why
can
not make hamburger pizzas?
We can make turkey hamburgers
Hi, buddy.
without buns in a
You've been so
tortilla,
good.
a single
You've been
tortilla.
so good.
We have a single tortilla, and maybe 2 slices of bread.
No, we're going to break out
all the leftovers and smush them together. Oh, look at Frodo!
There he is.
He's so cute. Him and Jack would have a great time. I love his ears.
He wants to play.
He wants to pee, probably, on things.
Well, you know, I mean...
But he shouldn't have to, because he's already been outside a couple times today.
I mean...
I know, puppy. You just
maybe
have a lot of
he has
anxiety.
Leia's bladder.
You just got the anxieties.
Just like Leia. Although...
We got our 4th training coming up on Tuesday.
Yay!
He's doing so good. He's good at healing. He knows place. He knows sits. He has recall. He's good at walks. Excuse you.
He's a smart boy.
He's so smart.
How's
That's
he-
a problem.
How's with his biting? Has his biting gotten better? Or...
Yes. Oh, well, yeah, so he doesn't bite much at all unless like he's overstimulated and I try to correct his behavior, then he just lashes out and
Right.
okay.
Okay. Yeah.
Okay, well that's good.
Gosh.
Yeah.
So he's getting there.
He's getting there. I think in a year he's gonna be a fantastic dog.
Yeah, he just needs that.
Just gotta get there.
He needs that structure and that guidance and that love.
And good thing I'm here all this month.
Oh, you just jinxed it, dude.
No, I'm gone for 2 weeks this month. I'm gone for half of this month.
You're gone for half of this month?
Yes.
Where are you going?
Texas and then Arizona.
Are you bringing him to Arizona?
No.
Oh.
Not yet. Not yet.
Oh, okay. All right. How do you think he would do a scout?
I don't know, but Scout is the light of my life, and I'm not willing to try that yet.
How would Scout do with him?
Wouldn't give a shit.
Oh, okay. Well, then he would actually might do well with her because if she doesn't care about him and not reactive to him, then he might just be like, all right, whatever.
We'll see. Not this Christmas, though, puppy. Come here.
So which means we have to think about if we're actually going to get a tree because how will Indy bring down that tree?
I already thought about that. I already
and
thought
chew
about
on
that
that
yesterday.
tree.
Indy's bringing it down like
that
Legolas and
yesterday.
Malifaux.
Seriously.
I want
he
to get
be-
a tree because I want to see Indy go up the
You
tree.
want to see him go up the tree? Do we put anything on
Nope,
the tree
we do
then?
not put anything on the tree.
Let's have a bear tree.
buddy.
I do want to go get a tree, like a real tree.
Oh, I know a guy that sells trees.
Does he ship?
Yeah, is he going to be coming
That'd
out
be
here?
great.
Oh, if he sells out there, yeah, you just go pick one up.
Yeah. Let me get one of your trees.
Hi,
Yeah.
buddy.
Is he coming out? Is he going to come out with...
No, he's already. His lot is already open.
Oh, it's already open?
Yeah.
Of course it's already open. Oh, look
There
at that
he
face.
is.
Hi, buddy. Oh, I showed you the collar.
New yes. New
and then-
podcast mascot. Frodo.
So, of course, on the front leash, it says Frodo. It's very nice. Things like that. You can kind of see that. And on the back, it inscribes, this one who wanders is lost. And then my phone number.
Yes. Also, it's a collar, not a leash. I just want to...
I know.
I just do that.
Sorry.
Just had to...
But it doesn't really fit you
can't
anyway,
control
does it?
Myself. I can't
Doesn't really
control
fit you,
myself
does it?
From just being annoying. Did you measure his neck before you ordered it?
I said medium.
This
Sounds right.
is the problem with Jack, dog Jack, Planetarium Jack. Is that because of his build, he has those American Staffordshire Terrier shoulders, but then he's a smaller guy, so a small doesn't fit him, but a medium also kind of doesn't fit him, but a large is too big, but you kind of have to go with a large because of his shoulders for sweaters and dog jackets. But there is a website called Spark Paws that I do want to get him a little sweatshirt from because they're made for kind of like that
What's it called?
odd Spark Paws. And so we can get him like a cute little like hoodie.
Mr. Frodo.
That should fit him better. And can you just picture Jack in a hoodie?
Yes. He would hate that.
He would. Actually, he might like it.
Well, come here.
He was chilly earlier.
He would give us a sad look, but you know what? He always gives a sad look anyway. So nothing would change.
Oh, hi. Mr. Frodo here is getting a green cape with an elven brooch. And then we're going to go into the dome and put back in the background and take holiday pictures.
Yes!
Nice.
Yes. Oh my God.
I know, puppy dog. You want something.
He wants your love and attention.
But you were so good for the whole podcast. I thought for
very good.
I thought for sure shit was going to go down.
I thought we were going to be drinking
very
all kinds of...
All the animals have been very good for the podcast. The cats are they're in their cat tree.
They're in a cat tree.
They're in the cat tree, which we need to get a second cat tree to have in that room and
you know
our
what?
room.
We're going to need a cat tree for every room.
Oh, what a cute boy. Look at him. Oh, Mr. Frodo.
Okay.
You saw our telescope, yeah?
Yeah, what's it called?
We don't have a name for it yet, but we did. Now that Mike did the alignment between the finder scope and the tube,
nice.
because my alignment, initial alignment, was very wrong because the finder scope and the tube are really not aligned. But we did get to show my family Jupiter, and all 4 Galilean moons were visible.
That's cool.
So it was phenomenal to see that. I'm very excited to see what this. It's an 8-inch Celestron, so...
Okay, there are 3 things I want next year, one of which may actually happen. Well, 1, a car would be nice.
Oh, a new car.
2, a house, because they're really fucking cute houses, and I really want one, and I'm definitely not talking to Linda tomorrow. And then 3, a solar telescope.
Solar telescope.
Yeah.
Those things are...
Pricey.
Okay, so did you test the solar filter to see
I did not.
We have an 8-inch solar filter from somewhere.
Me too.
And the scope's an 8-inch scope, so we're hoping that it should fit on.
But so specifically an H alpha telescope. That's what I want.
Yeah,
those they just look amazing.
But those things are expensive.
I know they start like $8,000.
Yeah, so I bought the telescope, right? And so you immediately start to get ads for telescopes and stuff. And I got an ad, and I was like, hey Liz, should we get this? And it was for a hydrogen alpha.
Oh God.
Yeah, $170,000.
Oh God. Yeah, let's play the lottery. You might need to choose between that house and that scope, though, Brandon, next year. Those are your...
I was like, how do you go from the telescope I got?
I know, you really got to get going. Okay, so this is what I'm going to do.
Should we call it?
Yes, I need to call it.
We're talking about bullshit anyway. So.
Thanks for joining us on The Hangover with Cosmos with Cosmos. My dog's about to take a pee, so I'm going to leave you now.
All right, we'll see everybody in 2 weeks.
Bye, everybody.
Cheers. Bye. Are we out?